Good morning all. Myself Arya K, second year MSc Microbiology, Central University of Tamil Nadu. Today I am going to present the topic called Overview of the Treatment of Industrial Effluents by Microorganism. What is industrial effluents? As we all know, what is it? It is the liquid waste products that is discharged from the industry. The effluents which depends upon the composition and the type of industry involved and the process involved. I will tell you the few about them. In manufacturing of the goods which containing the chemicals, heavy metals and the organic materials, and in case of the food processing industries, there will be the effluent from the food and the beverage industries, which rich in organic matter, fats, oils and nutrients. In case of the textile industries, there will be the wastewater containing the dyes, detergent and the other chemicals used in the fabric processing, and the chemical manufacturing process which contains the hazardous substance, which include the solvents, acids and alkalis. And in pulp and paper company, there will be a wastewater rich in the lignin, cellulose and the various chemicals which is used in the pulping process. And we know the pharmaceutical companies which also contain the toxic compounds, and in case of mining process, there will be the heavy metals, sediments and the chemicals used in the ore extract. So there are two types of methods, which is the aerobic treatment method and the anaerobic treatment method, which is used for the remove the industry effluents. That is first of all, aerobic treatment method, which is the this method decomposes the waste rapidly without producing the unpleasant odors. And there is three methods which are under this method, that is trickling filters, oxidation ponds and the activated sludge process, that is ASP. So ASP is the most widely used in India. Here the bacteria here the bacteria which responsible for the removing the waste in aeration tank with dissolved oxygen. It can remove the organic nitrogen, phosphorus and organic carbon substance. And the microorganism, here the microorganism grows and forms a particle that is settle at the bottom and produce the clear liquid free of organic materials and suspended solids. It is a cost effective for large cities and small facilities like hospital or hotels. And the ASP the main drawback of it is the sludge bulking and forming. That is produced by the that is caused by the filamentous bacteria like Nocardia, and the sludge bulking can controlled by increase the sludge wasting rates to reduce the sludge. Sludge, and the forming indicates the biological activity that is remove the that is controlled by removing older sludge. Third, there is a bed of porous materials, that is synthetic media or rocks, which supports the microbial growth, and this wastewater is distributed over the filter and allowing it to spreading through the media, and as it passes through the media, the aerobic bacteria on the surface which break down the organic pollutants in waste water. The main function of this filter is the organic waste removal and the biofilm formation. The porous media which provides the surface for the biofilm formation. The microbes grows and consume the organic materials, and it requires very low energy compared to the ASP, and it does not produce the unpleasant smell. On screen we can see a treatment filter image. There was a fixed bed surface which contains the microorganisms, and also the rotary distributor are there, and the air entrance which provides the oxygen, and there is a influent which go through this bed, and the effluent is removed by a pump also. Next one is the oxidation ponds. It is the large shallow pond designed to treat the waste water with the help of the sunlight, bacteria and algae. Here the algae grows within the ponds. It absorbs the sunlight and produce the oxygen during the photosynthesis. This O2 is used by the aerobic bacteria in the oxidation pond, which break down the organic waste, and this broken down solids settle down in the ponds. So next one is the anaerobic treatment method, which is the well established technology for treating the wastewater. It produces the biogases, that is methane and carbon dioxide. This biogas is used to heat in electricity generation and upgraded into natural gas quality. And this anaerobic treatment is divided into two types, that is high rate system and low rate system. In high rate system, it has a short hydraulic retention time but long sludge retention time, which is also used to treating many types of wastewater. In low rate system, which have the long hydraulic retention time but equal sludge retention time, and it is used to treat the digesting slurries and solid waste. This biogas yield depends on the type, concentration of the feedstock and the process of conditions. And this anaerobic digestion is a multi-step process which break down the organic materials into methane and occurring without an electron acceptor like oxygen. The anaerobic decomposition, which involves the microorganism which convert the organic materials into the oxygen-free environment, and it produces the methane. So this process consists of the four phases, that is the hydrolysis by the fermentative bacteria. Here the complex organic material is converted into simpler monomeric constituent, and second one is the acidogenesis by the hydrogen producing acidogenic bacteria. Here the organic compounds are converted into volatile fatty acids and CO2, and third one is the acetogenesis by the hydrogen consuming acetobacteria, that is the fatty acids are converted into acetic acid and the H2, and the last one is the methanogenesis. Here the acetate, CO2 and the H2 are converted into methane gases, and each phase is essential for completing this process. So there are different reactors are used in this anaerobic method, that is first one is the fixed film reactors, which is effectively for the wastewater treatment, and it utilizes the materials like PVC, activated carbons or ceramic rings, which supports the growth of the biofilm. And some of the advantages of this method is the simplicity, that is it is easy to construct and operate, and it it is stabilizing this the method. And the limitation of this method is the it requires a high volume, and sometimes it causes the blockage, that is due to the increased biofilm thickness and high suspended solids, which also affecting the performance of this reactor. So next one is the upflow anaerobic sludge blanket reactor, that is UASB. It is widely used in the food processing, paper industry and chemical industry. Here the mechanism of action is the effluent enters from the bottom and it flows upwards through the sludge blanket, and this effluent is separated by a funnel shape to enhance the solid separation from the outgoing wastewater. From this the bacteria which develops a dense population, and it produces methane fermentation. Some of the advantages is that it have the efficient separation of the solids and liquids, and it is a quick processing of the wastewater, and it supports the dense microbial communities and the high loading rates. The limitation is the high solid contents, that is the wastewater which contain the solids which develop the dense granular sludge. So next one is the anaerobic fluidicide bed reactor. Here the fluidicide media are used, that is a small particle size media like sand or activated carbon, which is kept in a fluidized state. It requires the large surface area which provides the space for the biofilm formation, and it also enhancing the biomass and reactor efficiency. The advantages of this method is the which supports the increased processing capacity and resistant to inhibitors, and it is enhances the microbial contact by improving the interaction between the microorganism and the substrate. So the overall advantages of the anaerobic treatment is that it requires very low energy for pumping and recycling the effluents, and it reduces the sludge production, and it have a high load capacity for capable of handling very high organic loads, and it also have the long term sludge preservation, and it have the compact space requirement which requires the less space than the conventional treatment of the systems. The disadvantages of the anaerobic treatment is some of the methanogenic bacteria are highly sensitive to various chemical compounds, and the next one is the it is a time consuming process. Some of the microbial enzymes are also used for the treatment of the wastewater in industries. The Bacillus, Pseudomonas, Trichoderma are the examples of the microbial species, and in this method the enzymatic action are the enzyme which targets the specific contaminants, and it will break down the pollutants, and the types of the enzymes are the hydrolysis, oxidoreductase and transferases. This hydroxylase which break down the complex molecules, that is lipids for fats, and the oxidoreductase which facilitate the oxidation reduction reaction, and this transferase enzyme which transfer the functional groups for the detoxification. The mechanism of action of this method is the contaminants binds to the enzyme active site. This enzyme catalyzes and breaking the bonds and releases the products. So on screens you can see the some of the enzymes, microbial source and the pollutants. The first one is the lactase, which is from the Bacillomyces, white rot fungi and the Bacillus subtilis, and the Streptomyces griseus, which is mainly used to treat the pulp and paper industry wastewater. Mm. So next one is the lignin peroxidase, which is from Penicillium chrysosporum. It is mainly used to treat the textile industry wastewater, and some of the enzymes are mentioned on the table. You can go through on it. So these are my reference. If you want to know more about this topic, you can refer it. Thank you all.